The third type of miscellaneous equation that we're covering in this section is solving equations of the quadratic form, and we will be using a method of substitution for that. Before we get to actually solving them, I want you to understand what the quadratic form is. The following three examples are of the quadratic form. There are 5 properties that I'd like you to notice that are the same in each one of these 3 equations. If you'd like to pause the video right now and see how many you can find on your own, that would be a good idea. The first thing that my students usually see that is the same is that each of the equations are set in the form the expression is equal to 0. Notice that each one of the 3 are set equal to 0 here. The next thing your students usually see is that there are 3 terms. And I'll say on the left. We have 1, 2, 3 terms in the first equation. 1, 2, 3. Sometimes the last one's a little bit harder to see, but there really is 1, 2, 3 terms. Another thing students often notice is that the last term is a constant. The 9, the 2, and the 18 are all constants. So these are the 3 that usually students pick up on after I give them a few minutes. The next 2 are a little bit more difficult to see. Notice that in each of the first 2 terms, the base or variable we'll say variable part is the same. And that's in the first and second term. Let's take a look at that a little bit more closely here. This variable and this variable are the same. And the x and the x variable are the same. Notice the exponents are not the same, but the base variable part is the same. Even in the last one, the base variable part is the same on all 3 of them. The last similarity between the 3 equations are in the exponents, the relationship between the exponents. You have to look very closely here. Notice that in the exponent of the first term, has a relationship between the exponent and the second term. And if you look a little bit closer, you can see that it is twice the exponent of the second term. Let me show you that a little bit closer here. This 4 is twice as much as the 2. The 2/3 is twice as much as the 1/3. And it even works in the last one. It's a little bit difficult to see. The 2 is twice as much as the invisible 1 right here. So that is the last one right there. Now each of the 5 similarities to the right qualify the equations to be in the quadratic form. So let's go ahead and show you what the steps are and actually solve some practice problems. Solving quadratics of the quadratic form, we're going to be using substitution as we said earlier. First thing I want you to do is identify the equation as a quadratic form. And we just identified the 5 qualifying factors in order for it to be in the quadratic form. Next, I want you to set that equation equal to 0. On the next step, we're going to let some variable be equal to the original equation's middle term. So I'm going to choose the variable u. You could choose anything you want. You could choose the first letter of your name. You could choose p, whatever you want, as long as it's not the original variable. But I've seen a lot of books use the letter u, and so we're going to go ahead and be consistent, and I'm going to be using the letter u. So let some variable u be equal to the original equation's linear term, or we'll say middle term's variable part. This equation is very, very important to write down because we're going to be using it later in step 5. Next, I want you to find the square of the new variable u, which will always be the first term's variable part. So after we find what u is equal to, I want you to find what u squared is equal to. Next, we're going to substitute the new variable u into the equation to get a quadratic equation. And once we get a quadratic equation, we can solve for the new variable u. Although here in step 4 we solved for u, we didn't actually solve the equation that was given to us, usually an x. So to solve for the original equation, we need to then substitute the solutions into the equation from step 2, which, as I said, was really important to write down. Lastly, we have to check our solutions. This is mandatory if your equation includes rational exponents or any rational equations, meaning x is on the denominator. Now I know this sounds like a really complex process, but let's look at a couple practice problems and show you that it isn't quite as bad as it may look. All the instructions get a little bit daunting, but that's just because I want you to be able to refer back to them if necessary. Alright, so step 1 says, first identify it as a quadratic form and make sure it's equal to 0. Well, it already is equal to 0. I have one variable x in it. The third term is a constant. My 4 exponent is twice as much as the 2. Therefore, this is a quadratic form problem. Step 2 says let some variable u. So I'm actually going to write let u equal the original equation's middle term variable part. The middle term's variable part is x squared. The next step says find the square of the u that you just determined. If I'm going to let u equal x squared, what does u squared equal? Well, in this case, u squared would be x to the 4th. If it's of the quadratic form, which we just identified, that should be the first term's variable part. When I substitute the u's in for the x's, instead of x to the 4th, well, I can replace that with u squared. Instead of 8x squared, I can replace that with 8u. Minus 9 equals 0. Is this new red equation something I can solve? And yeah, that's absolutely something I can solve. I can solve for you, no problem. We've done a lot of quadratics in the past, especially in the last couple sections. So we are going to just factor this and find out that u is equal to 9 and u is equal to -1. The red part here is usually a very simple solve. Now the thing I want you to really truly understand is you did not solve for x. You did not solve the original equation. The original equation was x to the 4th minus 8x squared minus 9. The x, we needed to solve for x. No one asked you to solve for u. In fact, you're the one that brought u into this whole equation. You have to now take it out. You need to solve for x. So what we're going to do is to substitute the solution that we got into the blue equation that we have up here. I know that u is equal to x squared. So I'm going to replace u with x squared. And now I have two simple equations that I can solve. Take the square root of both sides, and I'm getting x is equal to plus or minus 3, and x is equal to plus or minus I. So I believe my solutions are plus or minus 3 and plus or minus I. Now I told you you could check your solutions. It's only mandatory if we have rational exponents. And in this case, I do not have any rational exponents, so I'm going to leave the check to you because it is not mandatory. Although when we look at the next problem, notice that we have rational exponents. So once I get a solution, which I know I haven't done that yet, but once I get a solution, I must check my work on this problem because I have rational exponents in my original problem. Okay, step 1. Is this equation of the quadratic form? Well, I have 3 terms. They are equal to 0. I have the same variable. My exponent on the first term is twice as much as the exponent on my second term. 1/3 times 2 is 2/3. So therefore, this does qualify it to be of the quadratic form. So I'm going to let u equal the variable part of the middle term, or the linear term. The variable part, which is u equals x to the 1/3. Next, I'd like you to tell me what u squared is. If I square both sides, I'm getting x to the 2/3, which just as a check should be the variable part on the first term, and it is. When I substitute, I'm going to go ahead and substitute into red, I'm getting 5 x to the 2/3. Well, x to the 2/3 I can replace with u squared plus 11 x to the 1/3, but x to the 1/3 I can replace with u plus 2 equals 0. Now I have a quadratic equation in red, which is very simple to solve for. This one simply factors, so I'm getting u is equal to -1/5 or u is equal to -2. Again, I do not care about u. I am only using u in order to solve for x. If you stop here, you will not be solving the equation, so you won't be getting all of your points. You really need to solve for x. Now, what I'm going to do is I'm going to look at the u, and I have an equation that relates u to x. U is equal to x to the 1/3. It is so critical that you write u is equal to x to the 1/3 down right in the beginning, because we're going to come back and use it right now. What is u equal to? Well, u is equal to x to the 1/3. And now I can write two simple equations in terms of x, and then I can solve them. Raising both sides to the 3rd power, I have a solution of x is equal to, do I need a plus or minus here, yes or no? Well, my original problem has a numerator of 1, which is odd, no plus or minus. So I'm getting -1 over 125. On the next equation, again, I do not have a plus or minus. -2 cubed is -8. And these, I believe, are my two potential solutions. I say potential because we have to check our work. And this does take a little bit of time. So here's my check for x is equal to -1/25. So we have 5 -1/25 to the 2/3 plus 11 times -1/25 to the 1/3 plus 2 is supposed to equal 0 if it checks out. The cube root of -1 is -1, and -1 squared is +1. In the denominator, the cube root of 125 is 5, and 5 squared is 25. Again, the cube root of -1 is -1. The cube root of 125 is 5. So that's 5/25 minus 11/5 plus 2. Is that equal to 0? Reducing this, I'm getting 1/5 minus 11/5, getting a common denominator. -1/5 minus 11/5 plus 10/5 is equal to 0. -10/5, and this is true. It does equal 0. And that was just the check for the first one. Next, I'm going to check x is equal to -8. Plugging it into the original equation, I have 5 times -8 to the 2/3 plus 11 times -8 to the 1/3 plus 2 is supposed to be equal to 0. The cube root of -8 is -2. -2 squared is +4. The cube root of -8 is -2. -2 times 11 is -22. And 20 plus 22, a -22, plus 2 does equal 0. So this also checks out. So both of these solutions are valid solutions. So -1/25 comma -8 is my solution set. X plus 3 quantity squared plus 7 times the quantity x plus 3 minus 18 equals 0. First, we want to identify it as in the quadratic form. It is equal to 0. We do have the variable part x plus 3 is the same in both the first and the second term. The first exponent 2 is twice as much as the second exponent 1. So this is of the quadratic form. So we are going to let u equal the middle term's variable part, x plus 3, and then u squared is equal to x plus 3 squared. Sometimes students get a little scared because they think they have to distribute this out. I would not. I would ask you, please do not distribute this out. It's not going to be any more helpful if you distribute it. We want to then take these values for u and substitute it into the original equation. Instead of x plus 3 quantity squared, I'm going to use u squared. Plus 7 times x plus 3, but instead of x plus 3, I'm going to put u minus 18 equals 0. Now we have a quadratic equation, which is much more simple to solve than the original problem we were looking at. This factors into u plus 9 times u minus 2. And my u solutions are negative 9 and 2. But again, I don't care about u, I care about, well, I do care about u, but I don't care about solving for the variable u, I care about solving for the variable x. So I'm going to replace x plus 3 back in for u. And now I'm ready to solve for x, the variable that I was originally trying to solve for. With some quick addition here, I'm getting x is equal to negative 12 and x is equal to negative 1. And that's my solution, negative 12 and negative 1. I don't have to check this. I could check this. I don't have to check this because my original problem did not have rational expressions in them or rational exponents. This completes our last video for the miscellaneous equations section. And we have covered higher order equations using factoring, rational exponents equations, and solving equations of the quadratic form using substitution.